Good morning, good evening, good afternoon, boys and girls. So let's go ahead and work on this lab. This is about path for address translation. Now, the first thing we have to do is configure zone access list. But before that, we have to reset the lab. So let's work on that. Do you guys remember how to reset it? It was something about the options and the reset. Let me try to remember. Reset activity. You go to file and reset activity. You click in OK. There you go. Now let me just add yes and okay. Let's start working on this. Okay, so what are we going to do in order to fully understand this lab and configure the path options and availability? Um, the first thing is go to router one and configure an ACL, an access list. This is to allow traffic from 172.16.0.0 network. Where is that? Let's validate 172.16 is the LAN traffic from this area, basically. So that's the first thing we have to do. So let me just, something pop up for some reason. Let me just copy and let's go to router one. Okay, let's do the following. Let's go ahead and enable and config T and let's paste that first command. Okay, so we are configuring access for a specific network. It's an access list one. Next thing we have to do is configure a pool, and a specific pool. So let me copy this command. Let me just copy that. And let's go ahead and paste it there. Now, what are we doing here with this command specifically? We are configuring a router one NAT, a NAT pool that uses two usable IP addresses in the 209.165.200.232/30 network. That's pretty much what we are doing. These are the two IP addresses. And this is the net mask. Next thing we do, we have to add the IPNAT inside source list one and the overload command. Remembering that we are working in port address translation and this is overload command is essential for the command to successfully work. And that's basically it. So next thing we have to do is copy this configuration in router one as well. Let's go to a notepad. Okay, so I was working on previous labs with a student before, so I have to close those. Let's go ahead and work on adding that and removing the spaces. Okay, so we are configuring the application of the access list and the NAT to those specific serial interfaces and gigabit interfaces. So we are applying the ACL at this moment. So with this command, that's what we're doing. Let's paste it there. There you go. IPNAT outside, IPNAT inside, IPNAT inside. We're applying the NAT outside of the network to reach the ISP, Internet Service Provider, and the NAT inside to reach the local area networks. That's what we are doing. In fact, if we go to the diagram, that is what we are doing. We are routing router one. So we are applying that ACL inside for the local area networks for the LANs and outside to reach the internet. Okay, now were all connections successful? Let's validate that. We have to do um, probably a web browser in the PC to reach a specific location. Let's see if we can do it. Probably we need to reach the server. Okay, let me see that. Let me work on it. Let me work on it. I have to, let's look at the structure to see if we have more information about how to reach the internet or what kind of test we have to do. So it says from the web browser or each of the PCs that uses R1 as a gateway, access the web page for server one. So let's validate what is the IP address for that server one. Do you guys know? It's actually let's go ahead to the packet tracer. It's actually the IP of 209.165.201.5. Let's go ahead and do a ping test from those PCs. And we're working about this LAN. We're working about this LAN for router 1. So that's the only thing we are doing. So let's validate to see if we have full connectivity. Actually, it's giving a timeout, but the ping test is working successfully, but it is telling us to do the web browser. So let me just copy and paste it there. Let's go to the web browser. It might take a moment because remember, we're working on a simulation, not real equipment. So, okay, great. It's working in PC1. Let's go to the other PC. Let's go to the web browser. We have to be patient because we are not working with real equipment and sometimes it's slow. Look at that, it's not responding. So it's part of the simulation and the packet tracer. So in the meantime, let's see if I can access another computer. It's just crashing the whole lab. That's interesting. Now I'm wondering if I can save the lab because I don't want to lose everything I was building until this moment. But if it just crashes, I'm just going to copy paste the whole configuration for the routers and that's it. It's not responding. It's just crashing. Let's go ahead and close the packet tracer lab. Okay, I'm trying to save it so I don't lose the configuration that I was working on before. I don't want to lose it. So in case it closes, okay, I can do it. Let's do the ping test here. Okay, it works. It works. It's actually reaching connectivity via port 80 HTTP. And we are able to reach the server. Let's go to the other PC too. Let me go ahead and close those first PCs. Okay. I'm trying to close the other PCs and move to this one. So the first thing we have to do is go to the web browser. So let me just go to the web browser. And now we have to do the ping connectivity test, or basically the access to the website via PC2 and L2. So that's what we're having to do. We're just clicking enter, wait for a couple of seconds, and hopefully we will be able to reach the server. Okay. We have to be patient because sometimes it takes some minutes, some more of the time than we expected. There you go. Finally work. So let's go ahead and close that PC2. Let's wait for L2 to open up. Let's go to the web browser. And hopefully this one will work. And that's pretty much everything we have to do until this part of the lesson. Okay. Now it's crashing again. Let's be patient. We know it's part of the packet tracer lab that sometimes it just stuck. It shouldn't be this way, but they have doing some updates. They have been doing some updates in packet tracer, and it's been more stable during the last couple of years. But it's still having errors after all, despite all the efforts. So let me just close this one and let's wait for this to finally work. And let me just be patient. Okay, so now we have to finally do this one, L2. That's the last one we have to do. Okay, let's paste it there and let's click on go. And after a couple of seconds, you will see that the connectivity is fully accessible to the server, hopefully. If it doesn't work, we will have to troubleshoot, do some research, validate if the ACL is fully configured correctly. That's pretty much. It's taking more time than expected. I just click in enter and there you go, finally working. Okay, so we have validated that in this step, everything is successful. We are reaching the server 1. Let's do a show IP NAT translation in router 1. Let's go to router 1 and execute this command. Let's do a Control C. Let's do a paste. There you go. You can see the port address translations. NAT is successfully working. We are reaching port 80, which is a HTTP. And we are finally able to validate the public IP address is translated correctly to a private IP address. The public IP address again, and the public IP address, we have the inside global, inside local, outside local, and outside global. Those are the ones we have right there. Yeah, look at that. It means that the translations are efficient. We have successfully configured a NAT and port address translation for these specific networks. Let's go ahead and clear the drawings. What else are we doing, boys and girls? What else? What else? Okay, we have to go to do something similar to router 2. We have to start with the A access list in this case. So let's do a 2WR. Let's do a WR. Let's close router 1 for now, and let's move on to router 2. First thing we do, same thing, we are accessing with config T, and we are adding the access list. Now, what are we permitting this other LAN? We are allowing this network via access list 2. Next thing we do, we have to do the overload with the serial interface 11, which is the one that connects to the internet, router 2 to the internet. So let's go ahead and add it. Let's add that. Let me paste it there. I got an error. Let me just do it one more time. There you go. Finally works. Okay, then we have to do the same process. We have to allow the outside and inside. This is to apply the ACL successfully. So let me just copy and paste this information. Let's remove all those spaces that are not required. Okay. Okay, be careful. And let's just paste that in router 2. Great. Now, let's go ahead and do only 2 PCs because we don't have time to do it. And, it takes a lot of time. So let's do L4. And let's try to reach it via web browser. And L3, PC3. Let's do PC3 and L4 only. Because it gets stuck like this, and I don't really like that it takes so much time. So much of our valuable time looks like there is an error, but let's just ignore that and let's do an end here and a 2WR just to save the configuration. If something needs to be corrected, we will work on that later. 209.165.201.5, and there you go. Let's go to PC3. Let's go L2, L4 actually. Let's go ahead and close L4, and then we can move on to PC3. Okay, we're almost finished with this part, this section. Now be patient because you are not working with real equipment and it takes more than expected. It's part of the learning process. Now, the reason because I've been doing most of the labs with Packet Tracer and not GNS3 or other tools is because for the CCNA purposes, you don't really need GNS3 or other emulation tools. For CCNP and CCIE, yes, you need it. But for CCNA, you can get certified with only Packet Tracer. I pretty much use GNS3 sometimes in other versions and other trainings per se, but it's not mandatory. It's not mandatory. I try to paste the IP address, but I am just adding let's just do it manually. 209.165.201.5. And there you go. After doing enter, on clicking enter, that's pretty much. We are able to reach everything successfully. Now let's save the configuration and let's validate how much of this activity we have successfully completed. We have done pretty much everything, 100%. Now, let's go ahead and go to the instructions to see if we are missing something. Yeah, we have to do the show IP NAT translations in router 2. So let's go to router 2 and let's work on that. So we did it before in router 1. Now we're doing this. And look at that, how beautiful. You can see the HTTP port, which is actually port 80, and the translations of the IP addresses. as well. You can see the inside global, inside local, outside global, and that's pretty much the translations of public IP addresses into private IP addresses to reach the LAN networks. Okay, let's clear this and let's move on. The next command, and I don't know if Packet Tracer supported because you remember some commands are not supported in Packet Tracer, is show IP NAT translations, show IP NAT statistics. I mean, let's try that. And it finally worked. There you go. You can see the show IP NAT statistics, and it's giving us some information of the kit, of the misses, expired translations, interfaces where the NAT was successfully applied. We have the outside, we have the inside interfaces, and we have done this configuration with the IP NAT outside, IP NAT inside, depending on the specific interface where we were applying that. Okay, next thing we do, we have to do the same thing in router 2. We have to, router 1, I mean. We go to router 1 and we execute the same. We are going to take a look at that explanation in a moment. So let me just paste it there. There you go. Now, router 1 lists dynamic mappings for the pool of addresses that has been configured. R2 only is only using the outside interface as the address to translate internal addresses to complete the dynamic mapping, basically. And you can see this information right there. You can see when you are executing in router 1, show IP NAT statistics, you can see the validation of the NAT for the outside interface, the inside interfaces. There is 45 hits. There is a total of 10 misses for expired translations. And you can see the information for the specific access list that we configured for this router 1, for those specific IP addresses. That 134 and that 133 allocated is 1, there's a 50%, and a total of 2 addresses. That's basically what we are doing right now. So we can have a better and clearer explanation of some of the information that we can see here with the show IP NAT statistics command. What else do we see? Let me clear the board for a moment. We see that there is a total of 5 translations, total translations. 5 are dynamic, and those are also, there are 5 extended. So that's pretty much, that's everything. Let's go ahead and clear the board for now and see if anything else is missing. We may have to do a show IP NAT translation just to close the lab, show IP NAT translations. And that's the last thing we are going to do, validating what we have here. The public IP address is translated into a private IP address or vice versa. And this is a connectivity to port 80, where we were doing the test connectivity from the different PCs to finally reach the server. I think we're pretty much done with the lab. This has been a really dynamic, interesting lab. We have been doing some access lists, allowing some traffic, adding the pool of NAT, applying those specific NAT configurations to the interfaces, finally adding the overload command with the IP NAT inside source list for that specific ACL, and adding a pool name for that specific pool when we apply successfully the NAT translation. So it's been a pleasure. I remember practice makes perfect, and I'll see you at the top of success. Take care, boys and girls. Until next class.